lesson is going to be, wait, first of all, hi, I hope you are all happy and healthy and doing absolutely fabulous. And from the bottom of my heart, I hope you are all doing well. Okay, that being said, today's lesson is solving and graphing inequalities. So we are going to round out this school year with inequalities. So if we look at the vocabulary, in means not. So these are things that are not equal to one another. These things are going to be greater than or less than, more, all sorts of relationships that are not equal. So the standard says to represent a real-world problem using linear equations and inequalities in one variable, so there should only be one variable that's the same, including those with rational number coefficients. Rational numbers are going to be fractions and decimals, and variables on both sides of the equal sign. Solve them fluently, explain the process used, and justifying the choice of a solution method. So previously, we've just done equations. Today, we are coming back and doing inequalities. And so the expectation is that students will be able to represent a real-world problem as an inequality, solve the inequality, graph the solution, and interpret the solution on a number line. So let's get started. So some prior knowledge that we have going on in this. If I asked you to solve this, all of you should be able to solve this. So as a quick reminder on how you solve this, you should have remembered D, C, V, which means distribute. And what I'm looking for when I see the distribute is parentheses. Do I have parentheses here? No. So I'm not really going to need to do that. Combine like terms. That's when the same terms are on one side of the equation. So here there's, nope, there's nothing we can combine. Move our variables to the left. So to move our variable term to the left, we do the opposite operation, and the opposite of 3x is minus 3x. And whatever we do to one side, we do to the other. And I'm writing this underneath the x because, oh wait, it's an x term. Remember, there's an invisible 1 hanging out here. So this is going to be negative 4x minus 4 equals negative 2. And then we do the opposite operation, which is to add 4 to both sides. That becomes negative 4x equals 2. Divide by negative 4. And x equals negative 1 over 2, negative 1/2. So step 1 is going to be distribute if there's some distributing. Step 2, combine like terms, move your variables to the side. And then we're going to solve it with the ultimate goal of getting x by itself. Move the opposite operation, don't drop that negative. Oh, don't drop that negative. Okay, same thing here. Well, I don't have anything to distribute or combine or any variables on the left-hand side, so I just drop my equal sign, box my variable term to keep it safe until later, opposite operation, bring down my variable term. Sorry about my writing. I know it's not beautiful today. And then opposite operation. Well, you should be like, wait, I don't want to deal with this fraction. You cannot change it into a decimal because that is a repeating decimal. And then that changes your accuracy. You should change it to a reciprocal. And whatever you do to one side, since we just multiplied this times the reciprocal, we're going to multiply this side times the reciprocal. These cancel out, so we're just left with an x on this side and then we can use our Desmos calculator to find, doesn't want to work. Well, the answer to this is going to be 12. Cancels here, 4 times 3 is 12. Okay, and then the last one that's in prior knowledge, again, this is all review. The first thing I want you to do when you see a line like this is, put the number, when you have just a single number, put it in the center. Now, always put a circle on the line, not above the line, on the line. Now, if there's an extra line, there should be extra color, meaning you are going to fill in the sign. This is because this says X is less than or equal to. If it's equal to, we have to include the -3, which is why it's filled in. And then everything that is less is to the left. Now, some of you may have said, all right, well, my teacher before told me to just turn this into an arrow and it will shade it that way. Okay, that is only true when the variable's on the left. So in this situation, I can't do that. Because if I put my 5 here and I put my open circle, because it is greater than, it says 5 is greater than y. Well, if I just follow that, it would be this way. But when I read it, starting at the variable, it says y is less than 5. That means I've drawn it in the wrong direction. Y is actually less than 5. Now, another way that this can be helpful is you could flip-flop this around so that y is less than 5. I call this flipping this like a pancake. So when the variable term is on the right-hand side, flip the entire thing over like a pancake, and that way you can use your other tricks. So extra line, extra color, no line, no color. Maybe flip it over if you do not like it there. Okay, now this notes page is available on Canvas. If you would rather do it on paper, you are absolutely welcome to write it on paper. Just make sure you've copied everything down. Next thing we're going to focus on is vocabulary. And so some of the vocabulary we need to look at is because we're looking at word problems. So looking at this vocabulary, we have these 4 symbols. These 4 symbols we are going to drop. I'm going to change the order of our symbols so that they match our graph. Okay. Actually, I can't do that, so yes, I can now. No, I can't. All right, well, maybe I can. So sorry. I should have been more prepared. Okay, now they match. So I want you to write them in each of these columns as we go through and look at the vocabulary for some of the words. Now, you might look at this and say, okay, well, this is less than. So yes, you could bring is less than into this box. Oh, this one will be is less than or equal to. This one's greater than, this one's greater than or equal to. But we have a lot more words that actually show these variables. So at least. So I like to think of is at least for being like an age or a height that you need to do something. So you need to be at least 16 in order to get an official driver's license, a real driver's license in Indiana, not a learner's permit, but a real driver's license. And I didn't say that you must be at least 16 in order to drive, because that's not the truth. But at least 16, that means you must be older than 16. So it is an at least, even though it has a least, it's actually greater than or equal to. So make sure is at least goes in the greater than or equal to. Is greater than is pretty simple. It's just greater than. Minimum. So the minimum age to vote is 18. Well, that means it's the smallest. It has to be bigger than that. The minimum number of people that have to be on the Google Meet is at least 1 in order for me to stay on there. That means there can be 1, there cannot be less than 1. It has to be greater than, and it can be equal to. So minimum can be equal to. So it is a greater than or equal to. Above is just simply the word greater than. No less than. So there can be no less than 5 school days missed before you get in trouble. So once you hit no less than, so you won't get in trouble if there's less than, but as soon as you hit no less than, it has to be greater than or equal to. Below is going to be less than, is less than, obviously is less than, is at most. That means it's going to be less than or equal to. Maximum is also going to be less than or equal to. No more than. Well, you would think because of the word more than that it can be greater than, but it's not. It's no more than. So it is less than and equal to. Is more than is another word for greater than. Exceeds. That means it goes above. It exceeds my expectations. That means it is greater than. And then is fewer than is another word for is less than. So please make sure you have each one of these vocabulary words and phrases written down into those boxes so that you have them as a reference as we move forward. But I don't like word problems. Yes, I know. No one really likes word problems, but it's what is being asked of you to do. So, Mario purchases a prepaid phone for $50. If the plan charges $13 per minute, how many minutes can Mario talk on the phone? Okay, so when I think about this, I need to think. Sorry, my computer is being overloaded. Okay. When I think about this, I need to think, all right, prepaid phone plan. So it's like a prepaid phone card. It has $50. Can he spend exactly $50? Yes. So whatever he spends can be equal to 50, but all of what he spends also has to be less than 50. So whatever it is that he spends has to be less than or equal to $50. Now, 13 cents per minute, or 13 cents for each minute, tells us we are going to multiply. So we are going, this is just the start. This is explaining how we're going to set this up. Then we're going to write 13 cents per minute for each minute. 13 cents times each minute. is less than or equal to 50. Now, how do we solve this? Well, solving inequalities is very, very simple. It's the same thing as solving equations, which is why we started that with the prior knowledge. So, opposite operation, opposite of multiply, is to divide. But the problem is that you must set up and solve this problem. You have to set it up first. So, m is less than or equal to, and then you use Desmos, 50 divided by, let's see if Desmos will work. Nope, Desmos is not going to work for us. Good. 50 divided by 13 cents. Getting my calculator out. I apologize. Calculator. 50 divided by 0.13. And this becomes $384, sorry, 0.6. So the last step in solving an inequality is interpreting it to make sure it makes sense. So the minutes have to be less than or equal to 384.6. So if you rounded this number up, you would go to 385. Because we're going to say how many minutes. It doesn't say how many partial minutes, it says how many minutes. Can he talk the entire minute of the 384th minute? No, because he has a decimal here. So we can say that Mario can talk less than or equal to 384 minutes. Roderick needs at least. So here we have the vocabulary word at least. So if you looked ahead or looked at the word bank, at least means that it's going to be greater than or equal to $560. So he knows at least $560 to pay for a spring break trip. He is saving $25 from each of his weekly paychecks. So each tells us to multiply, and he's saving $25 each week. Well, how do we solve this? This is one step, is to write it. Step 2 is to solve it. And we do that by doing the opposite operation. And again, you use a calculator. 560 divided by 25 is 22.4 weeks. Well, he doesn't get his paycheck in the middle of a week. He gets it on the same day each week. So it cannot be 22.4. We have to interpret this in terms of this problem. So it's not going to be the weeks, how long before he can pay for his trip. It's not going to be 22 weeks. It's going to be the 23rd week before he can pay for his trip. And he could pay for it anytime after that, but it would be greater than or equal to 23 weeks. Stay on the swimming team. Angie must attend at least. So we see the phrase at least again. And at least is going to be greater than or equal to. So that whatever it is has to be at least 3/5 of the study table's sessions offered. So she has to go to at least 3/5 of the study tables. She attended 15. That means 3/5 of the study sessions is 15. So when I have fractions, remember, I multiply by the reciprocal. What is the maximum number? Sorry, it would have to be minimum number because the number of sessions is at least 25. Nope, that would be the maximum because she has to attend at least. So I wrote that equation wrong. So if I'm looking at this, 3/5 x is how much she must attend, and this is how many she actually attended. And 3/5 x has to be at least. So it has to be greater than or equal to the other amount. And so x is a minimum of 25 lessons, or a maximum, of 25 study sessions. Not speaking well today, I apologize. Okay, Mrs. Jones wants to make at least $4,000 a month before taxes. That means whatever she makes needs to be greater than or equal to 4,000. Her job pays a base salary of $2,000, and the word "and" is a plus sign, a 10% commission. So when we talk about a percentage, we need to move the decimal 2 places to the left. I jokingly call that the booty cheek-it. So it is 0.10x. What sales does she need to meet? Well, we solve this in order to answer the question. We solve it by moving the constant, by doing the opposite operation. Bring down your variable term. Divide. So 2,000 divided by 0.10 equals $20,000 in sales. So she needs to make $20,000 in sales in order to reach her goal. If it has a maximum capacity, maximum tells us that it has to be less than or equal to 800 pounds. 4 people plan to go, so that's 4x, and then they have 60 pounds of food and supplies for the day. What's the maximum average weight of each person? Well, we subtract 60 from both sides. $740, and then divide by 4. So x is less than or equal to 740 divided by 4. Which is 185 pounds. So each person can weigh a maximum of 185 pounds on average. Roni is streaming a new release movie for $11.95 and purchased a few t-shirts. She was given a $50 gift card for her birthday. If tax and shipping total $10 and each shirt costs $9.99, how many shirts can she buy? Okay, well, so first of all, it's $11.95 for the video. And we're going to add on to this some t-shirts, and the t-shirts are $9.95 or $9.99. And then there's shipping and tax, which is $10. And this has to be less than or equal to the $50 gift card. So we're going to distribute, combine like terms, and move our variables to the left. We are going to combine this and this, which gives us $21.95 plus $9.95x. Sorry, $9.99x is less than or equal to 50. Then we subtract $21.95 . So 999x is 50 minus 21.95, which is 28.05. Divided by 9.99. That is x is less than or equal to 2.807078, anyway, 8, well, but it's a shirt. So can she buy an entire third shirt? No, it's 2.8 shirts. So she has to spend less than 2 shirts. Okay, my dog weighs 90 pounds. Okay, she's not quite that fat, but anyway. The vet tells me a healthy weight for the dog is less than 75 pounds. So I need my dog to weigh less than 75 pounds. A healthy diet will have my dog lose an average of 1.25 pounds each week. Okay, so I start at 90 pounds. She's going to lose, so it's going to be a subtraction, 1.25 pounds each week. Okay, and then I need to solve this. Drop my line, box my variable term, opposite operation. That's negative 15 divided by a negative. There should be an alarm going off in your head. Why? Because we just divided by a negative. The coefficient with the variable is negative. And so whenever we see a negative, whenever we multiply or divide by a negative, we must flip the sign. So instead of it being open to the right, it is now going to be open to the left. So W is greater than, and then you put into your calculator negative 15 divided by negative 1.25. And your answer is 12. So this means weeks are greater than 12. So it's going to be at least 12 weeks before my dog is at a healthy weight. Tori has $6 to spend at the ice cream store. Okay, so if you have $6, you have to spend less than or equal to $6. A sundae cost $3.25 plus 65 cents per topping. How many toppings can Tori order? Well, let's minus our $3.25 from both sides. So we have 6 minus 325. I'm bummed that Desmos will not work. That leaves us with 65 cents x is less than or equal to 275 divided by 65 cents. What's that 65 cents a negative? Nope. So do I have to flip it? No. 2.75 divided by 65 cents is 4.23, and it continues on for a lifetime. So let's think about it in terms of the real world scenario. How many toppings can Tori order? Can Tori order the 5th topping? No. Less than or equal to 4 toppings. Okay. Beech Grove is building a new playground and has 120 meters of fencing to surround the outside of the rectangular park. So here's the park. So this is the width, this is the length, this is the width, this is the length. So around the outside is going to be 2W plus 2Ls. And that has to be less than or equal to 120. Why? Because that's all the fencing they have. Now it says the width cannot be greater than 22. So I can replace the width with the number 22. So I can have 2 times 22 plus 2L is less than or equal to 120. Well, 2 times 22 is 44 plus 2L. Subtract our 44. To L is less than or equal to, now you use your calculator, 120 divided by, subtracted 44 is 76 divided by 2. Which is 38. So the length has to be less than or equal to 38 meters. It says, what are the possible lengths of the playground? Less than 38 meters. Okay, those are all the word problems. That's everything that we would need you to be able to do. So as long as you can do all of those, you're able to do everything we need for you to do for a word problem. Now this is kind of just as a reminder for more complex inequalities. So remember, the standard said with variables on both sides, one variable, variables on both sides, and being able to understand and do it with confidence. Okay. Drop your line, box your variable term, opposite operation. Bring down your variable term. Opposite operation. Ding, 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 ding. What's happening? Why is there an alarm going off? Because the coefficient, the variable term, we are dividing by a negative. So what must we do? We must flip the sign. The answer is wrong if you don't flip the sign, by the way. And this becomes -4. So x is less than -4. And if I were to graph that very quickly, I'm going to leave an open circle at -4 and shade it to the left because left is less. Okay, drop a line, box the variable term, opposite operation. 13, -2w, opposite operation. Woo, 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 woo. Why'd the alarms go off? Because the coefficient is negative. And so we have to remember to flip the sign. Flip the sign. So W is greater than or equal to -6.5. But Miss Wood, this says -6.5 is less than or equal to W. Yes, but remember we can pick this up and flip it like a pancake. And in which case W is going to be greater than, so we're shading to the right of -6.5. Okay, this one has variables on both sides. So remember you're going to move your variable term to the left by doing the opposite operation. Now, I used to tell people move the smaller one, but you know what? When it comes to inequalities, for some reason, students really prefer to have the variable term on the left. So, I'm flexible. So -21z minus 6 is less than 15. We add our 6 to both sides. -21z is less than 21. Divide by woo, 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 woo. Z is greater than -1. Oh, I did a very bad thing. Someone should be like, Miss Wood, you silly lady. On this graph, what didn't I do correctly? Well, it's or equal to extra line, extra color. I should have filled in that sucker. All right. D, C, V. Distribute. Combine like terms, variables to the left. Distribute. That is 12x minus 20 plus 7. 8x plus 3. Combine like terms. The only ones I can combine are the ones that are on the same side together, so I'm going to combine the -20 and the 7. So we have 12x minus 13 is less than or equal to 8x plus 3. Move your variable term to the left by doing the opposite operation, minus 8x. That is 4x is less, or minus 13 is less than or equal to 3. Opposite operation is add 13 to both sides. 4x is less than or equal to 16 divided by 4. X is less than or equal to 4. Because it says or equal to, I'm going to fill in my circle and it says less than, so I shade it to the left. Distribute. 6, negative 3v. Remember, you're distributing the negative 3. So 10 minus 3v plus 18. Why was it a plus 18? Because it's a negative times a negative equals a positive. Then combine like terms. We're going to combine the 10 and the positive 18. That gives us 6 minus 3v is less than 28 minus 3v. Move our variable term to the left by doing the opposite operation. So this should kind of confuffle you. You should be like, well, these are opposites, so they cancel. These are opposites, so they cancel. What do I have left? It says that 6 is less than 28. So my question to you is this a true statement? Well, yes, 6 is absolutely less than 28. So when it is a true statement, then it is all real numbers. Okay. Distribute. Remember, it's a negative 4. So we have 46 is greater than or equal to 8y minus 8y minus 20. And we have 8y minus 8y is nothing. So we have 46 is greater than or equal to a negative 20. Is that a true statement? It is. So it's going to be all real numbers.